So we are working on learning to apply combinations of transformations. So this is from 7C of the Unit 1 and 2 Mathematics textbook of Cambridge. So order matters with the combination of transformations. So if it's starting from a basic graph, we always go through using Dr. T. Dilation, reflection, and transformation. So dilation will come first before reflection. Dilation comes first, then translation. Now, sometimes you'll be given a graph and you're going to, it's already going to have some transformations that have already occurred. So you need to be mindful of this and how everything applies. Especially in some questions, it will say then already, so it will go against the Dr. T. But the general rule is we use Dr. T. So this is what we've already looked at on some of the rules. So with dilation from the x-axis, that means it's pushing away from the x-axis, so the y value is being affected. That's why it's got a times f of x, or a times y. Then we've got dilation from the x-axis. So in this case, from the y-axis. From this case, it is pushing away from the y, which is our x value is moving. So that means we've got FB of x. So whatever our x value is, it's affecting that. Then here we've got reflection in the x-axis. So reflection in the x-axis means the y value is changing to a negative or changing to a positive. So we've got a negative f of x. Reflection in the y-axis, whoops, just ignore that extra negative there. I'll just delete it right now. Pen. Okay, so reflection in the y-axis, we are just going to ignore that part there. And it's just our x is going to be having a negative there, so it will flip over to the other side. Likewise, we've got a translation, so horizontal shift is our h, and plus k at the end is our vertical shift. So let's look at this. In this case here, we are starting off with y equals square root x. So that is a basic graph. So because of that, we are using Dr. T unless it tells us otherwise. Dilation of factor of 4 from the x-axis, then reflected in the x-axis. So we apply dilation. It's from the x-axis, which means it is affecting our y value. Our y value is square root x. So it will be y is equal to 4 times f of x, which is just 4 square root x. Then it's being reflected in the x-axis. So we're going to apply that, which means we will be placing a negative in front of our y to reflect in the x-axis. So that means it will end up being y is equal to negative 4 square root x. Again, we've got a basic function here, y is equal to 1 over x squared. We're going to look at a dilation of factor of 3 from the y-axis first, and then translate it to plus 2 right and minus 1 down. So if we think about that dilation of from the y-axis, it means that it is pushing away from that axis, so the x value is going to change. So because it says dilation of factor of 3, so our x is not by itself, that also means that this 3 will be x over 3, because when we get our x by itself, to bring that 3 over, we are dividing, which is what I've shown before. So that will give us 1 over x over 3 in brackets squared. I will then simplify that by saying 3 squared is 9. Now this is really saying 1 divided by x squared over 9. So we can keep, change, and flip. And that means the 9 will be on our numerator and becomes y is equal to 9 over x squared. Now I just need to apply the translation. So the translation was plus 2 right and negative 1 down. So we're using our h and our k here. So our h is just going to be negative 2 here, and our k is going to be take away 1. So we've got y is equal to 9 over x minus 2 in brackets squared, take away 1. Now we've got a original function again of y equals x squared, and we're doing some transformations here again. We translated 3 left, 4 up, followed by a reflection in the y-axis. So normally we'll do Dr. T in that order, DIT, but it's asking us to do transformations first. So step 1 is the transformation, the vertical and horizontal shift. So my basic form is y equals fx minus h plus k. So now it says translated 3 left, so it'll be x plus 3, and 4 up is plus 4. I'm substituting that into x squared. That gives me y is equal to x plus 3 squared plus 4. The next part is we are dealing with reflection. So we're going to apply reflection here. That means it's saying reflected in the y-axis. So all of y will need a negative. So I just put it in brackets and I put a negative in front of it. The negative goes in front of the x plus 3 bracket, and it changes the 4 to a negative 4. Okay, find the equation of the image of the graph y equals 3 over x plus 1 minus 4. So now we're dealing with a graph that is not the basic form. When a translation of 3 units in the positive direction of the x-axis followed by a dilation of factor 2 from the y-axis. So if we're going to apply that transformation, we start off with that translation of 3 units in the positive direction, which means we are just taking 3 away from our x. Because we know x minus 3 by itself would be 3 shifts to the positive direction. That simplifies to x minus 2. And now we've got a dilation of factor of 2 from the y-axis. So we're going to apply that dilation. Now, because it says from the y-axis, what is happening is it means that it's pushing away from the y-axis and it's our x value that is being affected. So that's the major thing we need to be thinking about right now. So we'll just be substituting x over 2 into our equation. Now, if we look at this and substitute that in, I'm just going to get y is equal to 3 over x over 2 minus 2, and then take away 4. I'm just going to leave it in this form for now because the main thing I want you to take out of is how to be writing it and how to be input it. But if you can, have a go at simplifying this fraction. You'll need to make the denominator the same of 2 and then use keep change flip. Let's have a look at the final question where we've got find the equation of the image of the graph of y is equal to x plus 3 to the power of 3 take away 3 when it's reflected in the y-axis followed by a dilation of factor 2 from the x-axis. So we're going to apply reflection in the y-axis, which means the x turns negative. That's the first step. The second is we're doing dilation. And a dilation from the x-axis means all of our y value is going to be times by that 2. So that means I'm just putting 2 in front of everything. Be mindful, I've got extra brackets here because the 2 must times by everything. So now if I simplify this, the 2 goes out the front here and the 2 times with negative 3 to get y is equal to 2 negative x plus 3 in brackets to the power of 3 take away 6.